we did use Compose indeed, yes. And there are good things and bad things about it. The good thing is that Compose does bring you on its how do you say this in this language? Hold on a second. Oh yeah, delivers, that's the word. Okay. So Compose does deliver on its promises in regard that when anything changes, that is immediately rendered on the UI. Like, you don't have this trickery going on as you did with two-way data binding, where if you don't do what two-way data binding does, like for example, a simple view-related bug that if you call setText, then it overrides your cursor. So if you were to do two-way data binding against an edit text yourself, then you need to track the cursor position because it becomes 0. Like with Compose, it doesn't do that because it was built to handle changes coming from outside instead of the state being managed internally. That doesn't mean that you cannot have state managed internally, and we will definitely get to that because it's interesting. But basically, the way you can imagine this is that in Compose, the UI is always two-way data bound to the incoming state. Like anything that is wrapped as state and therefore observed as state and coming in as a function parameter, that practically is two-way data binding. But you just write standard code. You don't need to think about it. There's no magic. There's definitely no annotation processing. There's no like these fancy binding expressions and all the overhead of the generated code. Like that is generated by the Kotlin compiler plugin, but you never see it. You don't need to think about it. It doesn't break your build process, so it doesn't have all these shenanigans that data binding does. And you definitely don't have binding adapters, which is amazing because binding adapters were like the bane of Android code, to say it that way. Like people were abusing them in ways that they shouldn't have. But back to Compose. So the way you can imagine this is that you can change any variable anywhere, including your view model, because you probably are using one or something equivalent, unless you just throw everything into a composable, which is also an option. People are talking about it, how you probably don't need view model anymore, but that's also an interesting topic. But so let's say you do have a model, you change it. It is observed because you can have it in a live data or an RX observable or a state flow. It doesn't really matter. It's collected to, subscribed to, or observed as state, which means that it is converted into something that Compose knows about. And then that's the thing that you actually pass, like you pass the function, the dot value you get there, it is passed to the function, and that function will be reevaluated each time the state is modified. And this is what Compose tracks for you in the background. Yeah, the important thing here was that it delivers on this. Like, there is no bug about this. This actually works. So I'm not surprised that they released it as a stable in this regard. Like, this works. And it's actually quite fascinating that it does, because it's pretty magical.
But when you say it works, what would you expect to not work about this? What bugs would you expect?
Oh, that's actually a fun one, because you actually can run into very cryptic things if there's a version mismatch between your Kotlin version and the Compose version. And if you're really unlucky, then your Compose version and the Compose compiler version. Like, there was this particular bug where I got something like begin index does not match end or something like that, and that's practically what you get. And you get this huge stack trace from appliers and whatnot, and you're like, what am I even looking at? And the solution was to make sure that the compiler plugin has the right version. And this crash only happened when I tabbed 4 items and then navigated 4 forward. If I tapped 3, then it didn't, and I was like, what is this?
This was with Jetpack Compose.
This was with Jetpack Compose, yes.
And what caused this?
I don't know, version mismatch? Like, something to do with the generated code, right?
Okay, interesting.
Yeah, like this kind of arcane stuff can happen. So that's actually a downside of Jetpack Compose. You need to depend on a specific minor version of Kotlin, the specific one that is specifically supported by that particular version of the Compose compiler plugin.
But doesn't Android Studio warn you about this if they are not compatible?
Well, yeah, it just it makes your build fail. It says that this Kotlin version is not supported, but don't tell us we didn't warn you or something like that.
Okay. So when you had this bug where your app crashed when you tapped 4 things, were you ignoring this warning, or how did you get into the
Okay, so the
situation?
Kotlin version was correct. The problem was that there were two different versions of the Compose compiler plugin and
Okay.
Compose. So those became mismatched. Like one of them was like, I don't know, let's say beta 10 and the other one's beta 11 for some reason. And that's when it was like,
So to avoid these problems, we just have to make sure to use compatible version numbers.
yes. The tricky thing about it is that it was a runtime crash and it was very elusive. So that's something that people really need to care about. You need to use the right versions.
So those were some problems you ran into.
Well, one of them, yeah, I can also talk about like UI tooling wise and just tooling wise in general. That like so the build process is working well. Like you don't have the problem that you have with data binding, that if like every third build you do it fails and you clean the project and then you press it to run it and then it just works. Like Compose doesn't have this sort of problem, but the tricky thing about Compose is that if you used to rely on the XML preview to, like, for example, you cut out the image from Figma and you put it in as a background and then you position stuff to have like the right margins and all that, which is something that we used to do for complex UIs, but you cannot really do that with Compose because the way the preview works is that the preview requires a fully buildable version of your code, so you cannot have like half of it done, half of it not. Like the whole code base needs to compile for one, and for any change that is not just like a live literal, as it's called. So like if you need to add padding to something, then you say modifier equals modifier.padding and this number. Then you modified the structure of the code and therefore it needs to be recompiled for the Compose preview to be able to render it. So that means that if you like forgot something, you added a new view, you added like anything really, then you need to recompile the project, which is great when it's fast, but eventually it gets slower.
Yeah, literals don't require a rebuild, right? When you change
Yeah,
text, for
live
example.
literals don't. So text and numbers. So if you have this modifier padding 16.dp, then if you change that to 24, then that's a live
Right.
literal. And that's evaluated by the preview right there and then. You don't need to rebuild for that.
Right, but if you add padding when there wasn't padding before, then you have to rebuild it.
Yep.
And what do you think about the preview in general? It feels a bit weird to use. It's slow compared to XML.
Well, the slowness mostly comes from this that you have to rebuild so often for it. So in the end, you end up like writing this large chunk of code, hoping that it works, and then you wait for the build and then check the preview. And if something is wrong, then you, if you replace something with a row or I don't know, like you need to mutate the structure, then you rebuild again and again. And after some time, this actually took more time on some
starting the
complex views. No.
In my case, in my small app, I was faster actually starting the app and navigating to that screen than waiting for the preview. The preview was even slower than starting the app for some weird reason. Because I have to
Wow,
build
that's
the app
weird.
in order to start it, right?
Yeah.
But I don't know why it was slower. It was significantly slower.
Wow. Okay. I did not experience that. I did experience that sometimes Kotlin just like messes around for a long time and then I waited 2 minutes. So that was fun. Something I ran into, which I guess it's partly more like the API just didn't work the way I expected. Constraint layout. Sometimes there were cases when we swapped out the constraint layout to fix a crash, so that was fun. But on top of that, like there's this dimension parameter that you have to set on a constraint layout, where you have to explicitly say that it's field to dimension, field to constraints. I think that's what it's called. And if you don't know about this parameter that you have to set it, it's practically doing the same thing as when you need to set the width and height to 0 dp for the constraints to work. But setting something to 0 dp is a bit more obvious than having to remember that there is this other dangling parameter elsewhere that's like totally optional, that if you don't set it, then your constraint layout just refuses to care about the constraints you define. Like, I wonder why it's not the default. There are some strange API decisions there.
Yeah, I read a tweet about it from you, I think, earlier today about this problem.
Yeah. Because it's so strange. Like, you have to there are these things you have to remember, and that's almost a Compose job because there are so many things you have to put in a remember block in Compose. But for real, you have to remember that this property exists, and that if you forget it, then it just flat out doesn't work. It pushes your views out of bounds and stuff. And I don't know why that's the default. Like, you could redefine it to like, yeah, I don't care about the constraints, right? But this is a constraint layer. You would think that the default is for the constraints to like be taken into consideration, that you don't go out of bounds when you set the text view to be like between the parent and this view on the right, and it just goes off the screen.
Yeah, just want to mention that if people want to stay on track with these problems, they can follow you on Twitter because you post this stuff regularly.
Yes, I did
whenever you
post
run
about
into
it.
something. Yeah.
And then people eventually told me that you just forgot dimension field to constraints. I was like, why is this not the default? Like, is there ever a case when you actually just wanna push your views out of bounds? I don't know. That's weird.
Yeah, so I'm not 100% sure how I can imagine this. You set the constraints, but
if you forget this dimension parameter, then the constraints, like you say that I want this view to be the left constraint to be the parent, the right constraint to be this view on the right, and the way it does it is that it pushes it to be left of the view on the right, but it doesn't resize it to be within the parent. So it tries to put it there and it fails and it just goes off the screen. Like, the whole thing is just out of bounds.
But it can be fixed with modifier.
This dimension parameter, yeah. So technically you can configure it, but it's just not obvious. And well, yeah, you can read the manual. It does say that you need to set this parameter, but it's kind of strange to me that it wasn't like a property of like the constraint as modifier, for example, because you're probably using that anyway. So at that, or within the constraint scope, like you would pass it. I don't think you modify this later, but even then this is Compose, so if you change it, it would like reapply immediately. So I don't know why this property is optional. Technically, that's what I think about.
Yeah, I really enjoyed using constraint layout in XML, but I haven't used it in Compose yet.
I also love it in XML. You need to take that into consideration.
Yeah, but in XML, I know that you usually write XML code directly, right? I actually like the visual editor where you can drag and drop these different constraints. For some things, I found this very useful.
I have not used a visual editor in years.
But a visual editor was really useful in situations where you don't actually know how to achieve in code what you want, how the attribute is called that achieves what you want, and then you can just drag and drop these handles and it would do that for you. So this was, for beginners, I think this was easier.
Oh yeah, I definitely used the visual editor at the very start when I didn't really know constraint layout. I'm not saying that I was using it to create UI. I was using it to see what properties constraint layout has. And then I went into XML and I changed it up according to my new understanding. So
yeah, after a while, almost everyone started writing a lot of the stuff directly in XML because it's just more efficient.
It is, yeah. Like, I saw that there's this really cool button in the visual editor called Infer Constraints.
Yeah.
And then Android Studio tries to infer the constraints.
But did you find that actually useful?
I don't use it. I don't use it ever.
Yeah, I didn't find it so useful either. The only thing I used it for, I think, was when you put your first view in the middle of the screen and you want to have match parent constraints. Or add all these constraints to the sides of the parent. Then you click this button and then it does this for you, rather than having to add all these constraints manually, but this was basically the only thing I used this for, but not for anything complicated. But yeah, I think the idea of this was to put all your views without constraints on the screen, press this button, and then it connects them so that they stay in place, basically. But if you want anything that's a bit more advanced or anything complicated, then this won't do this for you, obviously, because it has no idea how exactly you want to have it. Yeah, what I like about the previews in Compose is that you can add multiple different ones of them. This seems useful. For
This
example,
is true.
you have different kind of states for your screen, and you can add previews for these different states, and you can all see them at the same time. This is really cool, in my opinion.
I definitely agree with that, because anything that you want to make configurable, you add it as a function parameter, and then your preview can just like swap out something that's like a true to a false, or change the items that you render, or you can even just pass in like no view, and I mean no items and some items, and then you render the empty screen on one preview and the list on another, and that actually works. That actually is really nice. And with that same setup, you can like check if dark mode is working or not. Like for example, that one of your previews is light mode, the other is dark, and it just shows both of them on the side. Oh, that was a fun one though. There was this minor issue that the screen was like growing kind of long, and I was like, okay, but how do you make this scrollable? And you cannot scroll it. You can't scroll the preview. What you can do though is redefine the height of the preview and make it like 2000 dp big, and then it works.
I had a problem that I sometimes added fill, how is the attribute called? Fill size or fill width and fill height, the modifier. And sometimes, even though it worked in the final app, the preview would break because it would make the preview extremely long because of this one composable. But this is not how it actually looked in the final result. So this was some kind of bug, I think. But there were situations where it completely broke the preview for me, because the screen would grow really large, and then I can't view it in the preview anymore. Did you run into this yet?
No, I did not.
The next time I run into this, I have to tell you about this or show it to you.
Interesting.
Because I had this a few times.
All this talk about previews reminded me of something that's super interesting, which is the required level of separation to make the previews work in Compose. Like, if you saw, there was a PR saying that now we support view models to some degree in a preview. I'm not sure what that really means, to be honest. But what is important though is that like you need to be able to set things up for the preview to work, right? Like you need to pass things in, and to pass things in, you need to create them. So something I ran into is that when there was no real separation, because, well, it was like our first third composable or something. So just directly pass the view model in. And so we pass the view model in, and for that we create it with the constructor, and the preview tells me that retrofit is crashing in the preview. And I'm like, what? And it's because there was a retrofit parameter that was needed because of the API error handling, right? Like for that you need the retrofit instance. So we were like, you know what, let's just cut some corners because this is the very start, we'll fix this later, blah blah blah. You know how that works, that always stays there forever in production. But oh well, that's not the important part. The important part is that if you needed a retrofit in your view model, then retrofit tries to also be created, and in the preview, it would try to detect what platform it's on with reflection, and it fails. It fails to be created. So at that point, you're like, okay, so that means I should not pass in any external dependency into this composable, otherwise it can potentially break the preview. And that's when you end up like separating it so that the incoming parameters are either data or something that's like an event handler, like a callback of sorts. And for that, higher order functions like onTextChange, string unit, that sort of thing. And then you'd never see the view model. You can pass in something like view model semicolon, is it semicolon, the two dots?
Just colon.
Colon, yeah.
But I think the operator has a special name. You mean the two colons right after each other, right?
Well, it's the function dereferencing operator, yeah, when you get a function reference. So what you can do is have this function like something that takes a string and returns unit, and then you just use this double colon operator to be like viewModel, uModel, two dots, and on text change, let's say that, because, well, I know no better name coming to my mind at this moment. But so you can pass it in that way, and then you don't need a reference to the view model anymore. And you do that a lot. Like, you do that a lot. So that's why a lot of people ask, hey, I have this composable that's like taking these 8 parameters and these 9 callbacks, and what do I do about it? And then people try to make these interfaces to like reduce it to like, yeah, I only need like one interface, but you still have these 9 functions. So technically you didn't really change anything. It's still almost the same. So in the case of composables, I actually found that I did not extract an interface for this because, well, the composable would be able to define a contract in this regard that I need these 9 functions to work. But in a composable, you cannot really define a class unless you do magic shenanigans, which you can, but nobody does. So in that regard, I'm like, so where do I name it? Do I just really actually put it next to this composable? But then in discoverability wise, it's not that good. So at that point, I was like, you know what? I'm not extracting this interface. I just pass in 8 callbacks. It's fine.
Yeah, interesting, because I actually do pass an interface that I have in the view model. So my view model implements this interface that contains all the methods that the composable screen can call on the view model. And then I have the benefit that I can just pass this one actions object, as I call it. You gave me this tip, right? Calling it actions. I only pass this one object down to the different composables, and they can then directly call these methods. And what I avoid through this is having this huge list of methods, method callbacks, and arguments in the outer composables that contain the whole screen. Because this was the problem. This grew huge, right?
Yes.
And this is also what you're talking about.
It's exactly what I'm talking about. So I did tell you that tip saying that this is something you can do if you want. In our code, I eventually opted not to extract an interface. So we just like kept the argument list.
So you have these large lists of arguments in your composable functions. Some people were mentioning, when I talked about this problem, some people were mentioning creating these state classes, but this is something different, isn't it? Because in the outer composable, you have to unravel them, I think.
You have to unravel them anyway, like you're going to access it from that object or that callback interface. Yeah, the state object is a different thing. The state object is a way to alter the state of something from the outside. This is most notable if you check things like the bottom sheet dialog as it works. Like you want to make it expand, but you cannot expand a bottom sheet rendered by Compose because it's a function. It's a composable that returns unit. It's not a thing that exists. So what's a thing with which you can communicate into the bottom sheet dialog so that it triggers a change that can be rendered? That's the question that we are asking. And the answer to that is a state class. You pass in, actually, yeah, you get this remember bottom sheet state. Let's go with that. And it has a function called expand, and that's what modifies the state internally. And this state class is what is also rendered by the bottom sheet. So as such, it's a way to extract internal state to the outside so that both the outside has a way to mutate it and trigger changes on the inside, but it also works on the inside because it needs it to render.
Okay, but what's the difference then? Why can't we just pass a Boolean value for the expanded state in, and the animation is then handled internally?
In their case, it's because it's a suspending thing. It's like, I guess they could have used the launched effect.
Because I went through these code labs from the Compose pathway that people can find in Google, and they basically said if you have composable functions where you have like argument and callback to change it and multiple of them, then you should create these state classes that just encapsulate them so you don't have so many arguments. So this is what I recommended basically, if I recall it correctly.
I have to look at it again because I know which one you're talking about, but I need to check again.
But
That's
what I was
fun.
going at was, I think with these states, if you do this for every composable, then you could
There it is, creating a state holder. Oh my god.
then
Okay,
you could decrease the number of arguments you have in the outermost composable, right? Maybe you can cut them in half because you always combine one of these arguments with one
Yeah,
of the
but
functions.
the reason why we eventually just didn't do this interface thing is because the internal composables don't need to care about every function. So at that point, I end up like splitting up this thing that I put together. And I'm like, why do I compose this thing together if all I do with it is decompose it again? But where am I going with this?
No, but what I meant was when you create these states, these state classes for every composable on your screen, then you end up with fewer of these method arguments, I think, function arguments in your screen composable. But I'm not 100% sure right now. But maybe we are going too much into the detail about this.
Nah, I think this is what people enjoy.
Okay.
The real question is whether we have an answer. My answer is to be pragmatic about it. So in this regard, when it was like, it had 12 parameters because I had like 7 data and 5 callbacks for change, then I was like, you know what, there's 12 parameters, but this is practically how composables work. So I don't care. It's fine. Like, it works perfectly fine. In fact, if you separate it this way, then you don't need to care about like if you have your data, then you need to annotate it with immutable and stuff so that Compose knows that this is an immutable thing, and then it detects internally with content equals and all that. But if you have these fine-grained parameters, then Compose only checks those parameters. So the more it's split up, the better Compose can optimize for getting diffs, like for observing changes. And that's the reason why I'm like, you know what, it's fine. Like, if you have these parameters, and these are the parameters that Compose observes, I don't need to think about how my structure affects Compose, because it is the most destructured way of passing this stuff in. This is what I need either way, so it makes sense that the composable expects these parameters. I look at it, I know exactly what it wants. And the exact reason why I was like, you know what, it doesn't matter that I have too many arguments. Like, why would I try to cut this down when it doesn't give me any notable benefit beyond cutting the number of arguments down? Is because if you ever looked at text, you're trying to use the material text in Compose, it has like 20 parameters. And I'm like, you know what? Let's just go with it.
Right. But why do you not like the approach where you have the view model interface so you can cut down on these function parameters?
I wouldn't mind it, but I would wanna create the interface as like a nested class.
So you don't want small composables to have access to all the methods that it shouldn't care about.
Yeah, that's these two things. Yes, like the small ones, they don't really care about all the other things. They only care about like on-text change, for example. And then I want to pass in on-text changed to that composable. I guess you can technically pass in an interface to the big composable, and the ones inside it would just get like actions, colon, and on-text change from that action. And then you can like have a hybrid approach where the small ones don't see everything, but the large one sees it as one argument list, so that it's not like this unsightly huge block of code.
I just want to clarify for people what I mean. The problem right now is you can't, or maybe it's not a problem, but right now you can't pass a view model down to composables as you can, but you can't show it in the preview. This was the problem, right? You can't
I'm not sure. For me, just creating my view model, which had a dependency on retrofit at that time, it made it so that retrofit couldn't be created, and you needed an instance. So then you have this you start to wonder, should I make retrofit nullable so that I can pass in null at the start so that the preview would work? And you're like, this is the opposite of what typed nullability was made for.
Yeah, and what I'm doing right now is I simply have an interface in the view model, and then I can, instead of passing the view model itself to the different composables, I pass that interface. And the benefit is that in the preview, I can then just use an empty implementation of that interface and it won't complain. So this is how I basically pass down the view model to these different composables. And why I do this so that I don't have these lots of different function arguments that the screen composable has to take in. Yeah, just to clarify this for people.
Yeah, I think either approach works because at the end of the day, we're literally just trying to pass some number of functions in some shape or form to a function. So like, whether you pass 8 of them or one interface that has 8 functions, I don't think it really changes anything. In the end, in the previews, we also just passed in these empty arguments. The important thing was solving the issue of like not having to depend on retrofit for a preview, because that would break the preview itself. Like it would literally fail with an exception during the preview process. So as long as you fixed the issue and it's like not adding too much extra complexity to your code, it's fine either way. Like the reason why I went for like keeping the argument list is that I don't want to introduce new concepts into the code that are not needed for it. That's what I felt.